let us discuss about the types of optimizers. Optimization algorithms are used to update weights and biases. That is the internal parameters of a model to reduce the error. So it can be divided into two categories: constant learning rate algorithms and adaptive learning algorithms. So what are optimizers? Optimizers optimizes the learning rate automatically to prevent the model from entering a local minimum and is also responsible for fostering the optimization process. There are many optimizers. We are going to discuss about few optimizers which are being currently used in the industry like ADAM, ADAGRAD, RMS Prop, gradient descent, and there are few more. So to understand this optimizers, we should have a quick review on loss function. So the loss functions are helpful to train a neural network. Given an input and a target, we calculate the loss. That is, we try to find out the difference between output and the target variable. So in regression problem, there are positive and negative errors. And MSE is the most common loss function. So what do we do here? We will be trying to find out the mean square error. So in classification problem, there is a probability of correct class in classification, and cross entropy is the most common loss function. Now let us understand with this example. We have X and this is the actual value of Y. In case if we try to find out the relationship between X and Y, immediately we can figure out that Y is equal to 4X. Since it is a simple relationship, we can find out that. Just think that it is a complicated relationship or the machine doesn't know the relation between X and Y. So first the machine is initializing weight as 2. Now, when weight is equal to 2, what will be the predicted values of Y? Since we have taken relation as Y is equal to 2X, it will get substituted in this equation and this will be the predicted value of Y, right? And if we try to find out the squared error for this weight 2, which is nothing but Y minus Y hat to the whole square, this is basically about the loss function, cost function we are trying to calculate. This is equal to 120. Now what is being done? The weight is little updated by or increased by 0.0001, right? So what is the equation now? Y is equal to 2.0001x, right? Now these are the predicted values of Y hat in which weight is equal to this. Now the squared error is being calculated for this. So from the actual value, and this is going to be the predicted value, right? Y minus Y hat the whole square. So now we get the error as 119.988. So from this, what we can understand, the error is getting reduced, yes or no? Because previously it was 120 and now we are getting it as 119. We have increased the learning rate just by 0.0001, right? So the error is getting reduced. Otherwise, we can try like weight is equal to 1.9999, right? Now, in this case, Y is equal to 1.9999x. Now, the squared error is being calculated and this is what our output is, right? Now, when the weight is reduced, the error is getting increased in this with this data. But when weight is increased, we are getting the minimal error than the previous case. Hope this is clear to you, right? So this is about the cost function, right? Fine. So in this diagram, what we can understand, this is being plotted between loss and weight. So this figure summarizes the steps where we check for the derivative and increase the weights if the loss decreases and vice versa before we hit where the loss reaches zero. So this place the loss reaches zero, because we are very much aware that in the previous case it was actually y is equal to 4x. When you consider this relationship y is equal to 4x, definitely the error is going to be 0. That we know. That is what we can see over here. The loss is going to be 0. But when the weight was considered as 2, the error was around 120. When the weight was increased, the error was getting reduced. That is why it is getting reduced, right? So when the weight was increasing, what was happening? The loss was getting reduced, right? When the weight was decreasing, we have seen that the loss was getting increased, right? So this is what we are trying to see, where we can reach this position. So what is our ultimate goal? Our ultimate goal is to reach this position. But how to do that? Our aim is to minimize to zero, right? So how are we going to achieve that? That is the great question for us to answer. So now let us discuss about the learning rate. The amount that the weights are updated during training is referred to as the step size or the learning rate. The learning rate is configurable hyperparameter used in the training of neural networks that has a small positive value, mostly in the range between 0.0 and 1.0. The learning rate hyperparameter controls the rate or speed at which the model learns. If learning rate is too large, it will result in weight updates that will be too large, and the performance of the model will oscillate over training epochs. Oscillating performance is said to be caused by weights that diverge. A learning rate that is too small may never converge or may get stuck on a suboptimal solution. So let me make it little more clear. In this case, we started with weight is equal to 2, and then we got some error as 120. Just think that I'm making the weight now to 5. So what will happen now? From here, it will move back here. Now again, if I reduce it to 1, again it will move here. Again it will move here. So that is why there may be a problem in reaching this minima, right? Global minima, right? So that is the reason whenever we have some whatever initialization we do, we have to take the steps carefully. Here the challenge is that if you take larger steps, it may oscillate here and there. If you take smaller steps, it may take a lot of time to reach this position. Hope this point is clear to you, right? So that is where we are trying to understand about the learning rate. So learning rate in the sense what we will try to do over here. So we will be having some old weight as well as the new weight, right? So what I'm writing now, I'm trying to find out the new weight, which is equal to nothing but old weight minus learning rate into dou L by dou W, which is nothing but the slope of this, right? So dou L by dou W means that is the slope of this. So we are ultimately trying to get the proper learning parameter, because this is going to be the step. So in the previous case, we were increasing it by 0.0001, right? So that is what we are deciding. And once we choose the learning rate, say now this slope is being negative. Now this is being over here. Now the slope is being negative. Negative into negative. So that what will happen? It will become positive. So the newer weight will get added up. The newer weight will get added up. Now in case we are here and the slope is being positive, when it is positive, positive into negative becomes negative. so that the new weight should be decreasing, right? That is what we try to save over here, right? Hope this is clear to you.